All right, everybody, without further ado, we're going to get started here. So I'm Sam Bakken. I'm Content Marketing Manager here at NowSecure. Thanks again for joining us for our webinar series, Mobile Penetration Testing, the Trilogy. Today, we present the third and final episode entitled Episode 3, Attack of the Code. And today we'll be discussing how to reverse engineer mobile apps and what security flaws you might find as a result. So, each episode in this series focuses on a different key area of the mobile attack surface that mobile penetration testing must cover. And we'll have the entire series available on our website, and I'll share a link with you at the end of today's presentation about where you can find that in case you need to catch up. Really quickly, I want to make you aware of a couple of ways to connect with NowSecure on mobile app security and mobile security in general. So first of all, I encourage you to follow us on Twitter at NowSecureMobile if you don't already. There you will find a number of resources that we share and some advice about mobile app security. I also encourage you to subscribe to our once-a-week mobile security news digest, MobSec 5, and that provides insight into the week's mobile security news. And you can also there sign up for blog updates and other notifications. And then finally, some of you are probably headed to RSA Conference 2017 in San Francisco in mid-February. So I encourage you to come visit us at booth N3334 and save a seat also for NowSecure CEO Andrew Hoag's conference talk, How Android and iOS Security Enhancements Complicate Threat Detection. He's actually presenting that at 2 sessions because RSA thought it would be a popular session. So if you click that link once you receive the follow-up email, you'll be able to save your seat there on your conference schedule. Now, I want to introduce to you today's speaker. On the line, we have solutions engineer Michael Kruger and mobile security researcher Jake Van Dyke. So Michael helps NowSecure customers design and implement mobile app security solutions. Previously, Michael was senior cybersecurity engineer at MITRE, specializing in digital forensics, vulnerability assessment, and reverse engineering. At MITRE, Michael helped multiple organizations build and maintain mobile app security programs through the evaluation and selection of tools, performing deep technical testing, and also coordinating across multiple teams of engineers. Then, on the bottom of your screen there, you see Jake Van Dyke. Jake applies both the app developers and researchers' perspectives to mobile security. He co-develops and maintains 20 apps on the Apple App Store and Google Play. He got his start hunting bugs in video game consoles and writing exploits that allowed people to run homebrew software on their Wii and Xbox systems. He was also the first inductee into Code Aurora Project's Security Hall of Fame for finding a number of kernel and bootloader bugs in Qualcomm chips. He's been at NowSecure since 2013 and discovered a number of vulnerabilities and released a number of exploits along the way. Finally, before I turn it over to Michael, we really want this series to be interactive, so please don't be shy about submitting questions to the host using the chat function in the GoToWebinar interface. You have a couple of experts on the line, and I want to make sure that you're getting your questions answered there so you can get the most out of this event. And with that, I'm going to hand it over to Michael. Thank you, Michael.
All right. Thank you, Sam, for the introduction, and welcome everyone to the final part of our 3-part series. Today, we'll start off by giving a brief introduction to reverse engineering and source code analysis. We're going to cover some reasons why reverse engineering, or RE, is a useful technique for application security analysis. We'll cover some techniques and tools to get you started into reverse engineering. Finally, I'm going to hand it over to Jake to show you some real-world examples. Now, as Sam said before, please ask questions as we go along, and we'll try to answer them towards the end of this presentation. So there are 4 main areas to focus on in mobile penetration testing. Commonly, we only test 1 or 2 of these focus areas, and we kind of forget the rest. I'm kind of guilty of that myself. But as security analysts, we really need to remember that to get a thorough assessment of an application, we need to prioritize all 4 of these areas. In assessing the security of a mobile app, you really should be looking at First part, forensics, which is ensuring that data is stored securely. Network, which you're ensuring the data is transmitted in a secure manner. The server side or the back-end testing, testing the back-end components to ensure that sensitive data can't be accessed. And then finally, what we're concentrating on today, code analysis. The native code really should be reverse engineered and analyzed from a black box perspective to ensure that that code can't be manipulated or that sensitive information can't be gained from that. All right, so let's jump into an intro on reverse engineering and touch on some source code analysis. So there's some debate among analysts as to what exactly constitutes reverse engineering. So to get started, let's define it as we see it. Reverse engineering is really the art of extracting knowledge or design information from a piece of software which the source code is not readily available. The process often involves disassembling a binary or library and analyzing its components and workings in great detail. And sometimes this is a very time-consuming, painstaking process. Now, reversing a piece of code, it's not always necessary if the source code has been if it's been shared publicly, on GitHub or some of those other source code repositories, or if you have received that source code through some other alternative agreement. However, the main purpose in both cases is still the same, and that's to understand the logic that's deployed behind these applications, their source code, and really find those vulnerabilities that could harm the user's assets, or really any kind of information that involves the customer and its users. Now, when analyzing a mobile application, independently of the platform, the most important thing is to determine if there is a security issue that could put that entire infrastructure at risk, or put the information that the user generates at risk after using that application. Now, the first step in reversing an application's code is changing it into something that's easier to understand by a human. What you see on the left-hand side is the executable code that's really only readable by the computer, versus the right side, which has been a first step transition back into some low-level assembly code that's starting to become more meaningful to us. But once you have an application, this is really the first step that you want to take before making any sort of attempt to reverse engineer. Why would you reverse an app that you have developed? Well, much the same way we do forensic artifact testing, black box network testing, we should be reverse engineering our own apps to validate the security posture of these apps. It's always better to find vulnerabilities before we release it out into the wild. So what should I be looking for? Well, API keys, AWS credentials, username, password, those are just a few things that we might find hard-coded into the code of the application. Should make sure that binaries are properly stripped of debugging info. Logging statements shouldn't be at the most verbose level. File and system names and native code should be stripped by the linker. And a proper configuration for a Java obfuscator should really be used. Now, the app's classes and the file names, they should probably also be renamed. And really, any sensitive strings should be encrypted. So even though you're hard coding those into the application, don't assume that they're automatically safe. Take extra steps to encrypt those strings even within the storage of the application itself. Now, developers, here's really an easy one for you. Don't leave those famous to-do strings in your code. Take those out. That's a hint for somebody else that you may have a bug in or around that code, and they're really going to hone in on those sections. So that's an easy one. A lot of common day compilers now have an option to just exclude those from the final compilation. Now, sometimes the final release will include a stripped executable and the unstripped executable side by side. So make sure you don't include any unnecessary files. Make sure you know what your output is and what is essential and nothing else. Now, why would you reverse engineer an app that somebody else developed? Well, Similarly to before, everything that we just talked about is applicable to those third-party apps. You may be using that app personally, you may want to include it within your enterprise, you may have somebody who relies upon you for that expert level knowledge that's asking you, is this a safe application to use? By safe, that's a broad term, but some of these people want to know, well, what is this application doing? Yes, from a network perspective, but also does it have any application that's compressed within it? Or what exactly does this application do, and can I use it without worrying that whatever else is on my phone or whatever I do is not compromised? Maybe using that app personally, or it may be somebody else. And since you may not know the developer itself, you really want to look for that third party, that suspicious behavior. A couple things you may find: hard-coded URLs, as I mentioned before, packaged apps within apps, malware. Large companies are often offering paid black box testing or even community bug bounties for identified vulnerabilities. Some other motivations that may drive reverse engineering efforts on third-party apps may be such things that range from, cheating at a game, unlimited swipes in an app like Tinder, unlimited skips in a music streaming app, free streaming on a Netflix or a Hulu, something like that, or even to alter the functionality of an existing closed source app, such as a banking application, to maybe remove ads or to add on certificate pinning, that network security level that we talked about in the last series, onto that banking app to actually make it more secure. And sometimes, as is for a lot of us, we just really simply want to learn more about the application or more about application security in general. So what questions does reverse engineering answer for us? Well, to name a few, it answers if you can tamper with an application. So a perfect example is that well-reported case of people reversing the Pokemon Go app. So I touched on before, cheating at the game. They wanted to know more about how the application worked. They wanted to know more about where the application, the geo-coordinates that application was calling and was presenting Pokemon that could be accessed. So really, a lot of the people just wanted to know more about that application. They also wanted to create third-party services to help users of that application. It was against the terms of services, but that's what those reverse engineers were really trying to do, was to expand upon that already successful platform. Another question that may be answered is, can you modify an app during runtime? Or does that app allow you, can you pull that app from a device? Can you disassemble it? Can you make some changes, perhaps point to a different library than it was pointing to before, or maybe pull out the crypto library completely? Can you re-sign it and reinstall it, and will it still work? These are questions that reverse engineering can answer for us. We can attempt to hook APIs using a tool such as Frida, which we'll touch on towards the end of the presentation, to get more visibility on the file system. We can investigate crypto libraries in real time, see how they work, what their calls are. We can observe network transactions prior to encryption. So this is as this network communication is happening, but before the final encryption layer is put on, we can see how that's working. We can even observe calls on writing to the file system. So we want to know where an app or what an app is writing to the file system in real time. This is a good way to do that, is by hooking those APIs. Now, throughout the presentation series, we've mentioned the OWASP Mobile Top 10 time and time again, and I just want to hit on it really quickly, because I really do believe that this is an important educational component. I highly recommend visiting their site, reading the material there, especially if you've never been there before. Right now, they do have a draft release candidate for the 2016 Mobile Top 10, so they changed things around a little bit. They've modernized it, so I encourage you to check that out. Now, today's discussion of reverse engineering is primarily focusing on areas 8, 9, and 10, so the code tampering, the reverse engineering, and the extraneous functionality. So back to what we were talking about before and what reverse engineering gets us. Well, similarly to that, what are some common vulnerabilities that we're actually finding during this process? Well, with API hooking, often seeing insecure network communication, we're seeing leaking of PII or personal information over the network. See such things as inter-process communication issues with Android, content providers that have directory traversal or SQL vulnerabilities. The reversing is also revealing such things as hard-coded encryption keys, or my personal favorite, an AES key with a null initialization vector. Other things for the reverse engineer, often very helpful logging is disabled at runtime, but some of those logging statements, and by logging statements I mean like the debug statements or the if-def statements and so on, those are available during static analysis. Those actually haven't been stripped out, and those are very valuable, give us a lot of information still. Oftentimes it gives us enough info to determine names of the classes and the variables that were properly stripped out, and we can replace those names back from those debugging statements. It's common in Java, but it's also common in C, C++, ObjectiveC style projects that are using non-standard tool chains. That'd be like your bootloaders or hypervisors. We're also looking for logic flaws or just easily circumvented security with reverse engineering. So we're finding a lot of these that you wouldn't find just by that standard dynamic analysis, but really digging into that code and sometimes even hooking those APIs. That's really what's bringing some of this to the surface. I mentioned a couple of the tools that could help. So APK tool, again, this is for Android, third-party closed. Dex2Jar and JD GUI are two of my favorites, and actually I believe Jake's going to hit on that here in a couple minutes. Frida, I mentioned, it's dynamic instrumentation, so that allows for hooking of some of these APIs. Very powerful platform. R2 is another reverse engineering framework. It's similar to, if you've heard of IDA Pro, this is a community-driven project. Does support DEX files or your Android type files. Class dump, clutch, and cycrypt are all driven towards iOS reverse engineering. In fact, I believe Jake may touch on those as well. Now, most of these tools are actually already included for you in a NowSecure sponsored Linux distribution called Santoku. So that is available, and when you receive this presentation, you'll be able to find that link to Santoku Linux, or you can just Google Santoku Linux and find the latest version available for download. Now with that, I'm going to hand things over to Jake, and I believe he's going to discuss a few examples.
Okay, so we'll start out with Android. I guess we'll go alphabetically here. So the first thing, you know, Android apps are packaged as APKs. So either you've got your own that you're thinking about uploading to the store, or you've got one that you pulled off the device, like you install it from the store and you pull it off so you can look at somebody else's app. And then in this example, we're using APK tool to return the app. We reverse it back into Smalley code, and you can see right in here we're using Tinder for the example, and in the Smalley you see that we've already got the class name here, paywall item iterator, and it's even got the source code file names. It's got line numbers. So there's a lot of this information they could have stripped if they would have properly set up the build system, and I think minify is what they call the option, but that wasn't done here. And so what this Smalley is, it's kind of like the assembly language for Android's Dalvik virtual machine. So you get a pretty accurate representation of the code that's going to be running whenever the app runs. So it's kind of it's not immediately familiar to most developers. So you've got to take the time to learn it, and then you'll see it's got like registers, and you'll move a variable between registers, and you can kind of patch it and make small changes with this, and you can even recompile it into a working app and install that. And that's one way, one of the tests you might want to do with your app to make sure that people can't edit your app and kind of redistribute it, change the functionality on you. So like I said, you can modify the Smalley code, but you definitely don't want to use that for big patches. Oh yeah, so moving on to the source code. If you don't want to take the time to learn the Smalley, you can see in the screenshot here we've taken the same class from the same app, and now we've gotten Java source code. And this is using the combination of dex to jar along with the JD GUI. So you feed the same app, you feed it to dex to jar, and it gives you a jar file, and then you can just open that up here in the JD GUI. And you'll see over here on the left side there's a panel with all these classes and directories and everything, and all this could have been stripped out. That would have really saved, or that would have caused us a lot more headache as a reverse engineer. But again, they didn't take the time to set it up, or maybe they just didn't care. So here we are looking at the paywall item again. Figured if we're wanting to hack the app and kind of get free swipes or whatever, this would probably be where I would start, just because of the name. So if they'd stripped the name out, then immediately you don't know where to start looking. And while we're talking about the Java, this is it's called decompiled code versus disassembled. And there's no real guarantee that this is the original source code that was used to make the app. It's just kind of what the decompiler thinks the source code looked like. So a lot of times you'll see bugs in here, and sometimes the decompiler can't really do anything, and you'll just get a blank screen staring back at you. And if you do see a bug in this code, you really don't know if the bug is present in your original source code, or maybe it's just something that the decompiler did. So you'll always have to go back behind and check it. And speaking of the decompiler bugs, they're a fun little tool, and they make work pretty quick sometimes. But one of the caveats is that I haven't seen any of them that work well enough to where you can decompile an entire app and then recompile it and install it and expect it to work. They're just not at that point yet. And then, along with Java, Android apps they're made out of native code. So the story on the native code, it's can we hop to the next slide? I think we're stuck. There we go. The native code, you kind of get the same choices as you did with the Java. You can disassemble it with IDA Pro or Redair, and that's what the image over here on the left looks like. You've got a list on the very left with some function names and imports and exports, and then you've got kind of a graphical representation of what's going on, the program flow and stuff like that. And the disassembly, that's a really, really accurate representation of what is in the binary and what's going to run on the machine. That's kind of one of the important things to take away here. It's not really familiar just looking at the the way it's structured and the words and the mnemonics, it's not really familiar to most developers. And then again, for every machine, every architecture, you're going to have different assembly. So you can have ARM and ARM64 and x86, and it's a lot to learn. And if you haven't taken the time to learn those already, then you may not know this well enough to even find a bug, even if it was staring you right in the face. So that's kind of why decompilers are becoming popular. And then you can see over on the right-hand side, this is the same function, but decompiled back into some C code. And you can see it looks like valid C. It's not probably the way a person would write it, with the way the variables are just named V1 and V2 and stuff like this, but it does have the proper syntax. And again, this is not necessarily the original code that was used to compile this binary. A lot of times the decompiler it'll leave whole chunks out. So don't expect it to do a super duper A+ job, because it's not going to. It'll work well enough to kind of give you an idea. And a lot of times that's enough to get you in the right direction. And then onto iOS, for those of you dealing with iOS. So I guess the first step again is getting an app. You can either start with your own, or if you're going to look at somebody else's, getting it from the store is a pretty easy place. Apple lets you download apps for free. You just have to have an account. But you will need a jailbroken device. So you would install it from the store and then onto your jailbroken device, and then run it and decrypt it there. And we use Clutch in this example. So running Clutch with the I switch, it lists out the possible apps that are installed, and then Clutch with B is what runs the app and then dumps it from RAM, decrypted, and creates you an IPA file, or I guess technically a mock-O. And then you back on your host machine, you can use SCP to pull the file off, and you see here we've got a mock-O, and it's got ARM and it says two architecture, yes, ARM and ARM64. And then you would just take the mock-O that you got and feed that directly into your disassembler again. And this, we used IDA Pro for this example. And you can see over on the left-hand side again, there's a whole bunch of those useful names that have been populated. And that comes from ObjectiveC, just by the nature of how it works. It's a really verbose language, and the disassembler is smart enough to find all the statements that make up the language and name some of these functions for you. So right off the rip, you can find like view controllers and delegates, and kind of get a feel for the entry point of the app, or if there's any functionality you want to look for. It helps you hone right in on that. And so it looks like in this one, we told it to disassemble the ARM64. So over on the side, you see it's got register 0 and register 19 and everything. And again, if you haven't taken the time to learn all your ARM and ARM64 disassembly, this is kind of a lot to take in. So maybe if you got some downtime, or maybe if work is going to pay you to do it, it would help to take the time to learn these things. And so what do you do now that you know how to disassemble and decompile and get some sort of idea what's inside the binary? What do you do with it? Well, the answer is there's not a right answer. There's just too many apps out there, and they all work a little bit different, and they've all got their own little idiosyncrasies. So in short, you've just got to dig around. You can take some hints. You can look for interesting keywords like password and crypto and money, stuff like that, paycheck, password. Just use grep or search in whatever tool you're looking for, and kind of hone in on those keywords and then see where they're used and kind of branch out from there. You can start at an interesting function and follow all the branches and parameters as inputs and outputs. So, and going back to that, the ObjectiveC we just looked at, if you know where your view controller, your main view controller is, you can kind of look where, like, you click a certain button. You know, when I click this button, it logs in, so you can kind of follow and see what happens when you click the login button. And while you're digging around, you'll look for logic bugs. Those are not always the easiest one to find. You've got to understand the application as a whole to really find those. The additional debugging info that'll jump right out at you. Like Mike mentioned, the debugging statements, the logs. Even if you've turned off logging or turned off debug mode, you still might have debugging statements in there, and those are really helpful. I can't say that enough. And this is also your chance to look at any libraries that you've linked into your app that you don't have the source code for. This is like Google Apps or the Facebook SDK or something like that. And you just want to make sure that it's not doing anything stupid or putting your users at risk, because once you've linked it into your app, it's your responsibility now. And that's like your users are trusting you, so take the time to look at everything you're linking in here. You'll look for hard-coded API keys, and if you've got credentials to any of your your testing servers or your dev servers, don't just leave your passwords in there. We've seen that one happen plenty of times. And then as far as API keys, sometimes they've got to be in your app. I mean, if your app doesn't know the API key, then it can't really use all your services. So you can look at obfuscating them, either maybe taking part of a string and adding part of a string later, or encrypting them. But if you just have like a long URL and somewhere at the end of the URL is like, and API key equals 1, 2, 3, 4 or something, that's just kind of giving it away. And a lot of times the APIs, they come with limits. So for example, Google Maps, I think you can use like 1,000 APIs lookups a day on the free one. And if someone just goes through your app and steals your API key, then all of a sudden they're going to steal all of your Maps lookups, and then they're going to use it for themselves, and your app is just not going to work. And next, looking for resources and other files that might have gotten linked into your final output. We've seen this one before. I think I saw Nintendo was really bad about this one. They would go through and their toolchain would properly strip everything out, and you'd have an executable file. And then as it was building the final product, it crammed in the original ELF file in there, which has all of your debugging information. So even though they stripped it, they still gave you that information in another format. A lot of times we see people include like the whole subversion or git directory in their app. So all of a sudden you just gave away your source code, and that could really hurt you if your competitors get a hold of that or something. So I guess that's about. I mean that should get you started. So the takeaways here are: you definitely want to reverse engineer your app before you put it on the store. You don't have to spend a month doing it. If you already know what's in your own app, you just kind of want to look through and make sure there's nothing really obvious and dumb. But while you're looking at the app, you'll get to see what somebody else is going to see whenever they do it. Because if your app has more than a few users or it's even remotely interesting, then somebody else is going to reverse engineer it. So you want to know what they're going to find out. So that kind of covers number 1 and number 2. And then while you're doing it, while you're looking around, I guess number 3 applies more to somebody else's app. But while you're looking around, you just got to be creative. You don't know what the developers were thinking, so you just hop around. Like I say, look for keywords and go from there.
All right. Thank you, Jake and Michael, so much for that information. So, ladies and gentlemen, we've had questions coming in. So keep those coming. Get clarity on anything that you need clarity on, because Jake and/or Michael will weigh in and help educate you on those items. So really quick, as we give them some time to just take a look at those questions really quick, I want to remind you that this was the 3rd episode of a series, right? So the series as a whole is called Mobile Penetration Testing, the Trilogy. We broke that into 3 episodes. You'll see there the Forensic Menace, Return of the Network Backend, and then Attack of the Code, today's episode. So if you missed any of them, I encourage you to catch up at the link you see there on your screen, which is nowsecure.com/webinars, where you can find all 3 of those episodes and really get a good overview of what you need to be looking for when you're performing some penetration testing of a mobile app. And so I really encourage you to take a look at all that good content. So, gentlemen, Michael, Jake, I think what should happen here is I'll probably ask the question and then just kind of jump in with your answer, and then feel free to elaborate on your colleague's answer. So first, this is kind of a more general question. I think it's good to start with this one. What is the difference between source code analysis and static analysis?
Okay, so static analysis, it's kind of encompassed within, or static analysis includes source code analysis. It's kind of the big umbrella. There's lots of different things you could look at statically, and one of those would be the code, the source code.
Great stuff.
Yeah, you can think of static analysis kind of as a big umbrella that includes everything, including that.
That's great. So here's another question. Michael, I think this might be in reference to sort of that earlier general introductory information, but Jake, I'm sure you have something to say about it too. Are to-dos or any comment added to the compiled binary?
So that depends on how you put them in there. If you put to do as a comment, then no, the compiler will ignore those in pretty much every language. That's the point of a comment. But we do see a lot of times people will put that in as a debugging statement. So whenever something happens in their app, it spits out in the log file to do, fix me, something along those lines. And in that case, it definitely does show up in your compiled code.
Great. Anything to add there, Michael?
No, that was perfect. Thanks, Jake.
Great. I'm going to throw this out to both of you. Is there any good/free alternative to IDAPRO without the need, that doesn't require a server, doesn't require the need of a server or require you to compile the tool? Do you guys understand that question?
So you've got IDAPRO. It's pretty expensive. Not gonna argue that one. They have a free version that you can use. It's I think they put limits on you. It will work for Android and iOS code, but they impose limits on you, so it's not the best option. There's Hopper, which is pretty popular. It's got a free trial, and I think the paid version is like $50. So you could go mow a couple of lawns and cover that one. Then you've got Redair. That one is free. I'm pretty sure he's got some stable releases. If you want, you can compile it from GitHub, but you can also just download and run it. It's got a little bit of a UI, but it's mostly in the terminal. So you're going to have to get familiar with the terminal.
Great. Another question, how do I deal with code obfuscation? And the example that's given is ProGuard.
So you really need to look for clues that are left behind to help identify those classes and variables. You know, it is going to be obfuscated. So as we talked about before, look for those debug statements, look for any of those that have been left behind to help you identify those classes, but really prepare to invest a lot more time in finding your way around. It's going to take some time to get past that.
Good. Okay, another question we have here is, it's like a question of judgment, but I don't know if either one of you have a favorite. What do you think is the best iOS apps decompiler, not disassembler?
I'm actually not familiar with any ObjectiveC decompilers. I've seen some that can go back to C, but I haven't seen any that go all the way back to ObjectiveC.
Same, Jake. I'm not familiar with any.
All right, great, guys. Thank you. What else do we have here? So, well, and you know, related to that question, I guess, because we use the terms decompiler and disassembler, what is the difference between decompiling code and disassembling code?
Well, really, they differ in one very important aspect. While both of them are generating human-readable text, the decompilers generate a much higher level text, which is a lot more concise and it's easier to read. So compare that to maybe assembly versus C code, right? Humans can read both of those, but one is a lot easier to understand. Disassemblers show a much more accurate representation of what's inside the binary, though. Decompilers, really, they're making a lot of educated guesses, and so as Jake mentioned in part of his presentation, just because you can decompile it doesn't mean that you can recompile it and have it work.
Anything to add there, Jake?
No, that's pretty much spot on.
Okay, great. So we have another question here, and everybody, I encourage you to keep these questions coming in. You know, we'll spend a little bit more time to answer anything that you think of right now. This is an interesting question, guys. So you may need to tag team it, but just jump on it. What do you think will happen when there are no more public jailbreaks? And this is obviously specific to iPhone 6s or iPhone 7.
So for iOS, you can take your IPA file and you can disassemble that one on your own. You don't need a jailbreak for that. Just before you upload it to the store. But if you're talking about somebody else's, like reverse engineering somebody else's app, then right now you kind of rely on a jailbreak to get the decrypted IPA. So you have to come up with something else for that. So internally in our own products, we use Frida, and we instrument the apps and re-sign those and install them, and then you can watch them at runtime rather than hooking the APIs of the platform, you hook the app itself, and that works pretty good for us.
All right, that's great. Another question, and I think this is from towards the beginning of the presentation, but what did you mean about encryption strings? Well, both of you, Michael or Jake. What did you mean by encryption strings? Does it mean obfuscation or really encrypt, decrypt strings during runtime?
Well, I'll let Jake weigh in as well, but in my opinion, that really depends on your string, right? What are you encrypting? Or what are you trying to protect? If it's just something that you want to protect from just a casual observation, then maybe obfuscation is sufficient. But if it's something you really, really do need to protect, some of those more sensitive secrets that we're talking about, then maybe encryption would be appropriate. But it does come at a cost. Jake, did you have something to add?
Yeah, I was going to say something along the same lines. So you can, like I mentioned earlier with the API keys, you can just kind of obfuscate those where you have half of it in one place and half of it in another source code file, and then at runtime you just add the two strings together. And that right there is going to eliminate a lot, like the lowest hanging fruit. But again, like you mentioned, you wouldn't want to do that with your social security number and your bank account information or anything. You would take the extra effort and encrypt those properly. Have your tool chain encrypt them, and then you can decrypt them at runtime.
That's great. On that topic, since iOS code is quite difficult to reverse, is obfuscation really needed, except for string encryption?
I wouldn't say that iOS code is any harder to reverse than Android. You do need, like we mentioned, you do need a jailbroken device just to get the app. But once you've got the app, you throw it at your disassembler, and you're already guaranteed, for the most part, to have the ObjectiveC debugging, or the ObjectiveC symbols and everything available. And once you're looking at assembly, the assembly is going to look it's the same language for ARM64 across Android and iOS.
Right on. Thank you for that. And then I think, questions are still coming in. We will try to follow up with you offline. But I think this is a good question to kind of, if we could flip to that last slide really quick. Well, let's start with Jake, and then Michael, you can weigh in. But if I'm brand new to this, where should I start? Like, where should I start? Of course, it depends. Of course, there's so many tools, but like, Jake, I wonder if you could just go in a little bit into like where to really get started with the tools to learn and things like that, getting into reverse engineering.
So if you're just getting started, I think it doesn't matter what you're just getting started in. It's always better to start with the free tools. So like I mentioned earlier, you look at Hopper and IDA, just the free versions. Don't go out and spend any real money yet. And whenever you're interacting with a device, whether it be Android or iOS, you're going to be using a remote shell with ADB or SSH. So you should learn how to use kind of the basic command line tools, ADB, fastboot, SCP, grep, cat, sed, find. Those are going to be how you use most of your time. I don't think there's too many big operations you're going to do where you don't end up using some of the command line tools at least a little bit. We've got Redair and Frida. They're both free options, and they're pretty powerful. but you'll have to invest more than just a weekend learning how to use them.
Great. Anything to add there, Michael, or did it sounds like Jay kind of covered it?
The only other thing I'd add is I'd also recommend a good way to start out, and what I did was actually pulling up on YouTube. There's a lot of introductory videos with experts walking through step-by-step an analysis of like an Android application. Highly recommend going to YouTube and looking up some of those. They're numerous. Some of them come from Black Hat or DEF CON or ShmooCon talks. Some of them are just individuals that are recording their analysis through an app, but it's really good to see kind of their thought process as well and kind of how they navigate through a specific tool. So if you want more information, I also recommend looking up some of those videos.
Great, and I just want to remind everybody on the line that we have a crack team of mobile security researchers at NowSecure, and those guys and gals are regularly publishing information about mobile app pen testing, mobile security in general, etc., on our blog. So please be sure to visit our website too to dive into a number of resources that we provide for people that are looking to make their apps more secure, whether that's through developers or that's people that are assessing apps against some sort of security standard. So with that, I'm going to wrap this webinar. Thank you, everybody, for joining us. Stay tuned. You will receive a follow-up email that will give you a link to this recording. We'll point you to the slides. And then finally, we'll have an issue of MobSec 5 coming out tomorrow. So I encourage you to go to that link right there and sign up right now so that you can make sure and get that issue that's going out tomorrow. So with that, thanks again, everybody, and we'll see you next time. Thanks.